Good morning, ladies and gentlemen. Welcome to lecture 4 of week 2 of this course on physical medicine and rehabilitation in sports. Today, we will be speaking on introduction to biomechanics and injury mechanisms. So, we'll try and understand how the body moves and what is the role of biomechanics in injury prevention and rehab. I'll be covering the topic as per the following outline: introduction, basic principles, role, biomechanics of different activities, tissue biomechanics and injury risk, role in rehabilitation and return to play, future trends, and conclusion. What is biomechanics? Biomechanics is the study of forces and their effects on the human body. It's very important in sports medicine because it helps us to understand injury mechanisms, it helps us to understand how to prevent injuries, and it helps us to tailor make rehabilitation strategies. The key areas are kinematics, kinetics, tissue mechanics, and movement analysis. If you have to study biomechanics, you should be aware of the three basic principles. One is Newton's laws of motion and their relevance. We should be clear about the concept of force, which is mass into acceleration, torque, which is the twisting force, and momentum. We should not forget that biological tissues respond differently to load, stress, and strain, and biological tissues have the ability to tear and later heal also. So, this will add a new dimension to biomechanics. It's not like normal physics, where if there is a metal fracture, it does not heal. Kinematics is the study of motion without considering the forces, for example, velocity and acceleration. Kinetics is the study of forces causing movement, for example, the ground reaction forces and the muscle forces. If you stand on the ground, there's an equal and opposite ground reaction force which is exerted by the ground. We must be aware about the types of forces which are acting on the body. For example, external forces such as gravity, ground reaction force, and impact forces. There may also be internal forces such as the muscle contraction, tension in the ligament, and the joint reaction forces. What is the role of the musculoskeletal system in biomechanics? The bones act as levers and the joints act as pivots. The muscles have a function in force generation and force damping also. The ligaments and tendons have a very big role in stability of the joints and movement of the joint. We must understand the force system which acts upon the joints during muscle activity. If you look at Fm, this is the force of muscle action upon the joint. Fy is the rotary force which acts on the joint during the movement. There is another force which acts at 90 degrees to the torque, that is called the compression force or the joint stability. Fg is the gravitational force which acts upon the joint. This is the angle of muscle insertion, and the formula for calculating mechanical advantage is Fm by F, G. So this is the force system which acts upon the joints during muscle activity. Now let's talk about the biomechanics of running and walking. We know that there is something called a gait cycle and it has got stance and swing phases. During every phase of the gait cycle, there is a ground reaction force which acts upon the body, and we must be aware about this impact on the joints. Energy efficiency is very important for walking and running, and a person who is more energy efficient can perform better during walking and running activities. If you look at this diagram, this is the gait cycle. We will look at the right leg. This is heel strike. This is foot flat. This is heel off and gradually moving to toe off. So this phase from heel strike to toe off, when the foot is in contact with the ground, is called the stance phase. From toe off to swing to the next heel strike is called the swing phase. Now, as you can see, this is a rhythmic cyclical movement which helps locomotion. Now, there is a duration for the stance phase, there is a duration for the swing phase. Stance phase is 60% and swing phase is 40% of the gait cycle. But when you start running, whole thing will change. And this we must be aware of during running and gait. This is when we talked about the walking and running gait. When we talk about jumping and landing, we have to be aware of something called force absorption strategies, and we have to teach our athletes how to land, how to absorb forces during landing. And there is a very important role of knee flexion and ankle dorsiflexion during force absorption. We must also be aware about the common landing related injuries, and we must train our athletes like soldiers. Soldiers are taught how to fall so that there is no injury. We must train the athletes in a similar fashion. If you look at a long jump, there are three different styles of long jump: hang style, stride jump and hitch kick. Now, if you look at the biomechanics and the landing of all three, they are different. So, we have to train our athlete in jumps as per his style and as per his technique. One size does not fit all. When you come to throwing and upper limb biomechanics, we must be aware that there are several phases of throwing motion, and each phase generates different forces upon the joints of the upper limb. We must be aware of the shoulder, the elbow and the wrist mechanics during throwing. And throwing is a very strong risk factor for overuse injuries, and improper throwing mechanics is another strong risk factor for overuse injuries. If you look at the phases of throwing, you have something called the wind-up phase, early cocking phase, late cocking phase, acceleration and follow-through. The wind-up, early cocking and late cocking is where the tension is built up into the tissues so that the upper limb can accelerate and throw the object. Follow through is the phase where there is maximum force being put on the shoulder and elbow ligaments, and this is the phase where you can have maximum ligament injuries to the shoulder and the elbow. When you talk about cutting and change of direction mechanics, there is a very big role about agility and foot placement. The foot has to be placed in a stable manner, otherwise there will be injuries. And the person, if he is indulging in cutting and change of direction activities, he has to be very, very agile. The knee alignment has to be proper, otherwise there will be injuries in cutting and change of direction movements. And there are very high forces which act upon the anterior cruciate ligament of the knee joint during cutting movements. So you have to work on stability of the foot, you have to work on agility, and you have to work on knee alignment, and then strengthening of the muscles around the knee joint. There are several common injury mechanisms in sports. Acute injuries are commonly traumatic, and we have also gone into the injury mechanisms of why acute injuries occur. Thus, intrinsic risk factors, extrinsic risk factors, inciting events, etc. Chronic injuries are generally repetitive stress injuries due to repetitive micro trauma and inadequate recovery. Injuries may be contact injuries due to contact with another athlete or contact with equipment, or injuries may be non-contact injuries in sports like running. Injuries may be overuse injuries due to repetitive stress and inadequate recovery. Let's talk about the tissue biomechanics and injury risk. We must understand that there is a load tolerance to bones, tendons and ligaments, by which I mean if you put more load on a bone, beyond its breaking point it will break. If you stretch a tendon or ligament beyond its breaking point, it will tear. We must be aware that there are some viscoelastic properties in tendons, ligaments and muscles which may protect up to a certain extent from injuries. But there are some factors which affect this tissue viscoelastic properties and adaptability, such as age. Extremes of age, tissues are not very elastic. Young age, children, adolescents, tissues are very, very elastic. If you are a well-trained individual, your tissues are elastic. And if you are giving adequate recovery time to your tissues, they will remain elastic and supple. Mechanism of ligament injuries. If we talk about anterior cruciate ligament injuries, they are mainly non-contact and it is because of a valgus knee stress. Most common injury to the ACL is because of the foot being planted on the ground and the individual performing a cutting motion, especially while running after a ball. And this is usually a non-contact injury and results in a pop or a snap being heard and the ACL being torn. Ankle sprains are usually inversion or eversion injuries. The ankle can invert and evert within a particular range. However, if that range is exceeded, there will be an inversion or an eversion ankle strain. Shoulder dislocations can happen if there is excessive external rotation and abduction of the shoulder, and this will cause the shoulder to dislocate by removing the head of the humerus from the glenoid cavity. Muscle strain and tendon injury biomechanics. We must be aware of something called eccentric and concentric muscle contraction. There are different forces which act during eccentric loading and there are different forces which act during concentric loading of the muscle, and the injury risk is different for both of them. The common sites are hamstring, quadriceps and Achilles tendon. And tendinopathy may develop due to a repetitive strain and inadequate recovery. Bone stress injuries. Bone stress injuries are stress fractures which are caused due to repetitive loading of the bone without giving adequate recovery. This is commonly seen in lower limbs and it's commonly seen in runners and soldiers. The common sites are the foot, the tibia and the femur. And there are several risk factors involved in this. Most common is sudden increase in training load. And there is a big role of repetitive loading in bone fatigue. And once this happens, the bone goes into stress fracture. The prevention can be done by proper load management and recovery strategies. Basically, you have to increase the load in a gradual fashion and you have to give adequate recovery time. Impact injuries and concussions. Another specialized area. Basically, the head is a bony chamber in which the brain is suspended in fluid. That is why something like this. It's a bony chamber with the brain being suspended in cerebrospinal fluid. Now, if there is an injury to one side of the skull, the brain will float and go and hit the inner portion of the other side of the skull, thereby damaging this portion. This is called contractile brain injury. And we must be aware of this. If we get a skull trauma to one side, we must also look for brain damage on the other side of the skull. So, the brain can be damaged in a linear fashion. There may always also be rotational injuries in the skull and the spine, which can happen during concussions. So, you may have a linear trauma to the brain, you may have a rotational trauma to the skull and the brain. How can you prevent this? By proper helmet design and by ensuring that the rules are followed always in sports where trauma to the head, face and neck can be commonly seen. Overuse injury mechanisms is basically a cumulative microtrauma and is rarely an acute trauma. Cumulative microtrauma without adequate recovery is the most common cause for overuse injuries which are seen. The common overuse injuries which are seen are shin splints, rotator cuff tendinopathy and stress fracture. And it is very important that proper training load management is done to prevent these injuries. You do require to give training load, but if you do not manage the training load with adequate recovery, you will get overuse injuries and your athlete will be taken off the game for a long period of time. Biomechanics of rehabilitation and return to play. When you are doing rehab for an athlete, you have to do movement analysis during the rehabilitation. Movement analysis can be done by 2D motion analysis and 3D motion analysis. 2D motion is done by video cameras. 3D motion is done by specialized 3D motion analysis laboratories with markers on the bony prominences. Nowadays, a new technique of 3D motion analysis has come in called markerless 3D motion analysis, and this allows you to see the human body while doing the motion in different planes. Before you return the athlete to play, you have to have proper strength and neuromuscular control training which has been given to the athlete. And before you certify return to play, make sure the athlete has undergone a functional testing program and certification by a sports physician. Role of footwear and equipment in injury prevention. We all know that proper footwear is very important, and we have seen the importance of well-designed footwear in marathon runners. Long distance running is a sport which has gained a lot by so-called smart shoes or motion shoes, and it has improved the timing of all these athletes. So, proper shoe design is important for performance enhancement as well as injury prevention. Make sure you're using the proper protective gear for your sport, and the gear has been designed as per the biomechanical characteristics of your sport. Orthotics for sports persons should be custom designed, and they have a big role to play in injury reduction. Nowadays, orthotics such as insoles, orthotics such as mouth guards, they are all custom designed and tailor-made orthotics. We must be aware of the gender differences in injury biomechanics. Ligament laxity differs in male and female, muscle activation differs in male and female, and joint alignments may be different in male and female. We must be aware of this, and we have to give a training program based upon these differences, as well as give an injury prevention program based upon these gender differences. We know that there is an increased risk of ACL injury in female athletes, and all female athletes taking part in sport should be put through an ACL injury prevention program. Prevention strategies should be tailor-made for male and female athletes depending upon age, sex, role of the athlete in the game, and the game itself. Fatigue and injury risk. Fatigue is a very big factor in injury, because as we may know, when you start getting fatigued during activity, the first thing which goes is neuromuscular coordination, and this will cause you to fall and get injured. Fatigue reduces proprioception and control over movements, especially fine movements. So, there is an importance of proper conditioning and recovery protocols to reduce fatigue risk. Technology. We talked about 3D and 2D motion analysis, capture systems, and there are also force plates and which can capture the forces which are acting upon the athlete, especially the ground reaction force and the force which the athlete is generating upon the ground. You have wearable sensors which give real-time data, especially surface electromyography and other sensors which give real-time data about what your muscle, tendon and bone and joints are doing in real-time data. There is a very big role of application of these motion capture systems, force plates and sensors in injury prevention and performance enhancement. If you know where your athlete is going wrong, you can give corrective measures. Emerging trends. Artificial intelligence is now moving into movement analysis. So you can learn, you can unlearn, and you can relearn the movements. Virtual reality is now being used for injury prevention training and for ergometric training. Wearable technology and biomechanical monitoring is now increasing by leaps and bounds, and we are now seeing a lot of athletes, professional athletes, elite athletes, being monitored in real time. The coach is sitting in some other city and he is monitoring an athlete undergoing training in some other city. Case study: ACL injury prevention program, very commonly seen in females, and we must look at neuromuscular training protocols for females. The key exercises are plyometrics, that is the jumping exercises, balance drills and strength training. Initially, it will always be balance, strength and then plyometrics. These drills and neuromuscular training protocols have been proven to be effective in reducing injury incidence in ACL. What are the future trends in biomechanics? Personalized injury prevention strategies, integration of biomechanics with AI and machine learning so that you can go into performance analysis, performance enhancement and injury prevention. And we are also looking at development of smart rehabilitation systems. Take home message: biomechanics is the study of forces and their effects on human movement. It is essential for injury prevention and rehabilitation in sports medicine. Biomechanics is essential for understanding injury mechanisms and optimizing performance. There is a big role of biomechanics in prevention, rehabilitation, and return to play decisions. And biomechanics, there will be an advancement in big advancements in technology to shape the future of sports biomechanics. These are my references, ladies and gentlemen. I strongly urge you to go through them. I have finished, ladies and gentlemen. Thank you for your patient listening. Thank you and Jai Hind.